In this exercise, we're given that a small company has found that its rate of profit in thousands of dollars after T years of operations is given by this derivative P prime of T equals parentheses 7t plus 14, close parentheses T squared plus 4t plus 8, close parentheses, raised to the 1/5. The first thing they ask us to find is the profit in the first 3 years. So that's the sum of year 1, year 2, and year 3. Then they ask us for the profit in the 5th year. Okay, so in this one, we're going to have to do profit of 5 years, take away the profit of 4 years. So we'll have to actually subtract off the first 4 years so that we can find just the 5th year, and then an analysis of what is happening over the long run. So the first thing we have to do is we have to find the integral from 0 to 3. And I'm going to take that 7 common factor out of the 7t plus 14 and leave that with a t plus 2. And then I've got a t squared plus 4t plus 8 to the 1/5. You have to always write this differential dt, or d whatever you are integrating with respect to. So basically, the derivative has been taken, and now we're going backwards. Now, whenever you have a complicated expression like this, you're going to have to use u substitution. So the first thing I'm going to do is I'm going to put that 7 on the outside, and then I'm going to go over here and I'm going to let u equal the most complicated part, t squared plus 4t plus 8, and then the derivative of u with respect to t is 2t plus 4, and I'm going to factor that 2 times t plus 2, and you'll see why in a minute. And I'm also going to multiply both sides by dt to get a dt over here. Now I'm going to substitute what I know, but before I do that, let's do it this way. Let's solve for dt. So 2 and t plus 2, we have to divide both sides for that. 2 and t plus 2. So this is what I can substitute for dt. So the 7 is outside, okay? I don't have anything I can substitute for t plus 2, so I'm just going to leave it there for now. This entire expression is u to the 1/5, and for dt, I can put in du over 2t plus 2. And now you can see, I hope, that this will reduce with that. The t plus 2's will reduce, and that's going to leave me with a 7 over 2, because look, this is in the denominator. I'm bringing him outside. Integral 0 to 3, u to the 1/5 du. So that's not a very complicated integral. It's just the power rule. So it's going to be 7 over 2 parentheses u to the 1/5 plus 1 divided by 1/5 plus 1 And all of that is going to be evaluated from 0 to 3. Now we got to do a little bit of arithmetic cleanup. So let's see, that's going to be a 7 over 2, a u to the 6/5, because 5 over 5 is 1, plus 1/5 is 6/5. All of that is divided by 6/5. And so that gets flipped over. 7 over 2, 5 over 6, u to the 6/5. And really, technically, once we do the u substitution, we don't leave these points here until we go back and we change our derivative in terms of t, because these values were for the t integral. So I've got 35 over 12, and now I'm going to substitute what u was, t squared plus 4t plus 8, t squared plus 4t plus 8. And now I can write that I'm supposed to evaluate it from 3 to 0. Don't substitute them in until you get the expression in terms of t. It's best just to wait here. There are some methods where you go ahead and change your t values, these t values, over to u values, and then you can sub them in. But I would just wait. Just wait till the very end and sub those in. All right, so now we've got to do this arithmetic. So we've got to be really careful. So it's 35 over 12 times 3 squared plus 4 times 3 plus 8, subtract, to the 6/5, sorry, almost forgot that. Subtract 35 over 12, 0 squared plus 4 times 0 plus 8 to the 6/5. So I'm going to clean up the inside. You could just put it in the calculator, but I like to just do a little bit more and get a number for in here. And then we'll do the same thing with a second set of parentheses. And we'll raise both of those to the 6/5. And I'll show you, it's a tricky thing about this exponent. So 3 squared is 9. 9 plus 12 plus 8 is 29. And then 0 squared plus 4 times 0 plus 8 is 8. So when I enter this in the calculator, I'm going to do 35 fraction key 12 left parentheses 29, right parentheses, caret key, parentheses 6 divided by 5. And you can use the division for this exponent or the fraction key. Subtract 35 fraction key 12. So use that fraction key again. Write that out. That's the ABC key. That'll do your fraction for you. Parentheses 8. Caret key, parentheses 6 divided by 5. That's the key to getting this right, is you have to put your exponent in parentheses. So I'm going to type this in. 35 fraction key 12, parentheses 29, close parentheses, caret key, parentheses 6 divided by 5, close parentheses. And I'm going to go ahead and do it to, let's see, they ask for the nearest dollar. So we're going to round at the end. So I'm going to go 4 decimal places, because remember it's in thousands and we're going to have to multiply by 1,000 at the end. 165.868. I'm going to go ahead and go 5 places. 86868, then there's a 2. I'm going to subtract, again, 35, fraction key, 12, parentheses 8, close parentheses, caret key, parentheses 6 divided by 5. And this is 35.36672. So I'm going to subtract that, 165.86868, subtract 35.36672 is 130.50196. Multiply that by 1,000 because they told us it was in thousands. That's 130,501.96. To the nearest dollar is $130,502. So that's for the first 3 years total.